This is part two of the slit diffraction problems. If you don't feel super confident on this problem, look at the last video. That'll give you a hand with the stuff, with what exactly this problem is talking about. But now I'm going to actually work towards solving it. So the formula that we want to use for this thing is d sine theta equals m lambda. And I explained in the last video why that was the formula we were using. And it's just a matter of pulling all the numbers out of the problem. So the number of lines per centimeter, that's just saying how far apart those slits are. A diffraction grating is just a whole bunch of slits, but you'll get the same answer as you would if you only had two slits. So don't worry about that. The same formula still works. Third order maximum means we're looking at the third maximum, so m equals 3. The angle is 23 degrees. Sorry about that. Let me fix it. 23 degrees, and the wavelength is 630 nanometers. Nanometers means 10 to the negative 9. Don't bother converting that to an ugly decimal. Just leave it like that, and it'll be nice and easy to plug into the formula. So let me work it out for you. Okay, working this thing out, you just toss in the numbers. I rearranged to get the d by itself because that's what we're looking for. And I threw everything else in, and I got 4.8 times 10 to the negative 6 meters. So those slits are really close together, but then again, they have to be to make light do this. We have one teeny tiny problem, though. The final answer that we got is telling us how many meters one line is, because the standard units in physics are meters when you get the final answer. But it wants how many lines there are for every centimeter. So we've got to do some kind of annoying conversions here, but they're not too bad. Let me show you how to do it. Okay, so to convert this thing, you get 4.8 times 10 to the negative 6 meters for every line that there is. It's a very small number of meters per line. And we've just flipped that. I want to know how many lines there are per meter. So you just take this number in here in your calculator and raise it to the negative 1 to flip the fraction, and I end up with this number. There are that many lines for every meter of this diffraction grating. And now we just want to know how many lines there are per centimeter. So should the number get bigger or smaller? Should there be more lines per meter or more lines per centimeter? Well, there should be more of the lines in a meter than in a centimeter. So what we end up doing here is we just divide by 100, and we can get the final answer. So if you do that, you end up just bumping the decimal place 2 spots. So 2083 lines per centimeter. And that does the trick. All right, I'm going to work out the next one on this same video. White light containing wavelengths from 400 nanometers to 750 nanometers falls on a grating with 7,500 lines per centimeter. How wide is the first order maximum spectrum on a screen 2.3 meters away? Hint, white light consists of all visible colors of the spectrum. Diffraction and refraction will be slightly different for each wavelength or color, which explains why a prism or a water droplet can separate the light into its colors. You've seen this in a rainbow or on a Pink Floyd t-shirt with that prism, where white light is actually all of the colors combined, and when you separate them, you notice. And what we want to see is what's the difference between what happens to like the red light and the green light. If I use two different lasers, like a red laser and a green laser, the dots that you would see, the locations of those maximums would be different because of the formula. And this problem wants to know how far apart those two dots are going to be. All right, to solve this thing, we need a formula similar to what we used on the last problem, but it's slightly different. This time it actually tells you where the maximum occurs, and that's this one. The location of the maximum equals, it's the same m and lambda as last time. L this time is how far away the screen is, and d is the separation of the slits, just like before. So let me start working this out. So basically what this problem's asking for is how far apart is the red maximum from the green maximum? So I'm just going to calculate both for you. Okay, so I'm skipping a few steps here because you guys should be pretty good at algebra by now. But got the whole problem set up, and we're just finding the difference between where the red maximum is and the green maximum is. And if you factor everything out, they have this in common. The only thing that's different is the lambdas. And when I throw those numbers in, I got that they were 62 centimeters apart.